Hi folks, this is a quick calculus lesson on limits and asymptotes. Let's go ahead and get started. So facts on limits and asymptotes. Vertical asymptotes occur when the denominator equals 0 and the denominator doesn't cancel out with any part of the numerator. When it does equal 0 but it does cancel out with a part of the numerator, then your graph has an open circle on it. So an open circle is created. So infinite asymptote limits are written as infinity or negative infinity depending on the graph's direction. So for example, here's a graph that has some infinite and negative infinites depending on which way you approach -2. If I approach -2 from the left, the graph is shooting down to infinity. When I approach -2 from the right, the graph is shooting up to infinity. Okay, so that's what that says right there. So this right here says when I approach -2 from the left. See that minus sign? This says when I approach -2 from the right there. Okay, so limits can be found by algebra, graphs, or charts. So an example, complete the table to determine whether f of x approaches negative infinity or positive infinity as x approaches -3 from the left and from the right. Okay, so here's a graph right here. So you'll have some of these on your test and on your homework also, probably. And we're going to approach -3 from the left. So here I am approaching -3 from the left. So it's smaller than -3. So I'm getting closer to -3, but from the left. Here I'm approaching -3 from the right here. Okay, actually it's going this way right here. So as I approach -3 from the right, it goes that way. So go ahead and I would plug this in my calculator into y equals. I have a TI-83 calculator. And then do the calculate feature and just plug in -3.5, -3.1. The Casio is real similar, I know. So you get those values right there. So check it out. When I approach -3 from the left, it's going down to negative infinity. When I approach -3 from the right, it's going up, it's getting bigger and bigger and bigger and growing to positive infinity. Okay, so there's negative infinity, there's positive infinity. All right, and vertical asymptotes you get by reducing fractions when possible, and then you set the leftover denominators equal to 0. If you ever have something like x squared plus 1 left over in the denominator, then you can't get a vertical asymptote out of that, because I can never have x squared plus 1 equal to 0. X squared minus 1 I can have equal to 0, but not x squared plus 1. So for example, if I said find the vertical asymptotes, if any, on this guy, here, this is x plus 2, x minus 2. Here, you'd factor by grouping. I'd GCF out of x squared out of both these guys, and I'd be left with x plus 2. Out of both these guys, I can only GCF out of 1. I'd be left with x plus 2, so they have a common x plus 2, and you're left with x squared plus 1. Okay, so here, those cancel, so I don't have a vertical asymptote from those guys right there. It's going to create a hole at x equals -2, but I'm not going to have any vertical asymptotes because x squared plus 1 will never equal 0 right there. Okay, so and then just verifying your graphing calculator looks something like that right there. All right, okay, if you're in my class, I would assign that for your homework.